Hey guys, it's Miss Glover. Today I'm going to be doing lesson 13, solving quadratic equations by completing the square. And this is an algebra 1 lesson for Eureka Math. All right, and so we have our first problem here in the opening exercise, and it asks us to solve for b. All right, so the first thing I'm going to do is I'm going to move everything to one side, okay? So what I want to do is I'm going to move the 2b squared from the left side and move it to the right side, okay? To do this, I need to subtract it from both sides, okay? So take 2b squared off both sides. All right, so you should have something like this. All right, and when I remove 2b squared from the left side, I will be left with minus 9b is equal to b squared minus 4b minus 14. Okay, so there's the steps there. Okay, all right, now I would like for the minus 9b to be moved to the right side as well. So it's a minus 9b. So the opposite of a minus 9b is a add 9b. So I'm now going to add 9b to both sides. All right, and this is what you should have. And once I do this, on the left side, I'm left with 0 is equal to b squared plus 5b minus 14. All right, so this is what you should be left with. All right. Now, what I want to do is I want to factor the two expressions, and here's what I'm going to get, okay? All right, and so what I'm trying to do here is I'm trying to think of two numbers that the product of those numbers will give me 14, but the addition or subtraction of these numbers can give me 5. Well, I know that 7 and 2 would work perfectly because 2 times 7 is 14, and then 7 minus 2 will actually give me 5, all right? So I'm going to write in my b because I know that b times b will give me my b squared. All right, we just said that it was 7 and 2, okay? Now, as I'm looking at my work, I notice that this 5 is positive, which means that the 7 has to be positive. And this is going to be negative because I have to get this minus 14, okay? But I also know that 7 minus 2 will give me 5, so perfect, okay? So I get 7, b plus 7, and b minus 2. Okay, this is what you should get. All right, now, based on the zero product rule, I know that one of these factors can equal 0. So what I'm going to do is I'm going to set them both equal to 0. So I have b plus 7 will give me 0, or b minus 2 will give me 0. All right, so this is what you should have. All right, and now I'm just going to solve for b. So the first one's going to be b is equal to minus 7, or b is going to be equal to a positive 2. And this is what you should have. All right. Okay, now I am going to look at number 2. Okay. All right, so I've written it on my paper. And as I look at this problem, I realize that I can't think of two numbers that when I multiply together, I get a product of 13, and then I can get a difference or addition or a sum of negative 4. All right, so this is going to require that I actually do something here. All right, and what I'm going to do is I'm going to factor out this 1/2, okay? All right, so this is what you have when you're done, okay? All right, now I'm going to complete the square right here by adding 16 inside of the parentheses because of this 1/2. All right, and how that's going to affect this whole equation is I have to now subtract 8 because of the 1/2 and the 16. So this is really going to be adding 8, but I need to do the opposite on the outside, so that's going to be subtract 8. All right, now I'm going to combine like terms outside of the parentheses. Okay. And then now I'm going to go ahead and factor this out. So I need two numbers that will give me a product of 4, and they will give me either the sum or difference of 8 or minus 8. All right. So the two numbers that come to mind to me are going to be 4. So the fact that this is positive and this is negative, well, that makes both of these minuses, okay? All right, now, because these two are the same, then I'm going to rewrite it and simplify. All right, and this is what I get. Okay, now we're on this one, example number 1, okay? All right, so for this one right here, it says that we need to solve for x, okay? All right, so as I'm looking at the numbers here, what I really want to do is I want to subtract 12 from both sides. But when I think about it, there's no two numbers that I can multiply together and get a product of 12 and then add or subtract and get a sum or difference of 6. All right, so what I really want to do is I want to go ahead and complete the square for the x squared plus 6. All right, and so what that's going to cause me to do is when I think about, I'm going to write it down. Okay, so this is what I'm completing the square for, all right? And whatever I'm going to do over here, I'm going to also do on this side, okay? So when I think about 6, I'm thinking 3 and 3. And so if 3 plus 3 is going to equal 6, then 3 times 3 is going to be 9. So I'm going to add 9. And the reason why I know this is addition also is because 3 plus 3 is going to be 6. So a positive 3 times a positive 3 will give me a 9. Now, because I am adding 9 to this side, I also have to add 9 to the other side. Okay, so this is what you have. All right, and so I'm going to now simplify by adding these two constants together. Okay, so now I'm going to factor out my left side because this is what I have now. And you may be tempted to take this 21 and bring it over here, but what's going to happen is you're going to do 9 minus 21, and it's not going to get you anything that you can work with. So we're just going to stick to going ahead and factoring out, okay? All right, so what's going to happen is I'm going to rewrite the left side by factoring. All right, and I know that this is plus 3 and plus 3. All right, and so this is what I have. All right, I'm going to rewrite this because x plus 3 times x plus 3 is the same as x plus 3 squared. Okay, now at this point, I just need to take the square root of both sides. Okay, so that's what I'm going to do next. Okay, so I took the square root of both sides. All right, and so the square root of this is just going to be x plus 3. And the square root of 21 is going to just be plus and minus the square root of 21. All right, and then I'm going to actually move the 3 to the other side. All right, so for my answers here, then I'm going to have x is equal to plus square root 21 minus 3 and minus square root 21 minus 3. All right, and I am done with that one. I wasn't even recording. All right, that brings us now to this problem. All right, rational and irrational numbers. It says the sum or product of two rational numbers will always be a rational number. All right, and this is actually something you should have learned in 8th grade. And then it says the sum of a rational number and an irrational number will always be an irrational number. The product of a rational number and an irrational number is an irrational number as long as the rational number is not 0. All right, now they give us this example to solve for. I've already written it on my paper. All right, and so the first thing I'm trying to decide is I want to see if every one of my numbers are divisible by 4, okay? And so I know that 4 is divisible by 4. 40 is divisible by 4. It's the 94 that I need to determine, is it divisible by 4? All right, so when I do this, nope, I get a decimal, so I know I can't do that either. So what I'm going to do is I'm actually going to move 94 to the right side of my equation, okay? And so this is what I get. All right. Now, once I move it, I'm now going to factor out the 4 from the 4x squared minus 40x on the left side. So divide everything on this side by 4. All right, and I have this. Okay. All right, now I want to complete the square. All right, and the two numbers that come to mind are going to be 5, because I know minus 5 and minus 5 will give me 10, right? And then 5 times 5 is 25, but because of this 4 on the outside, I'm not going to just use 25. I'm going to put 25 here, and it's going to be a positive 25. But to keep the equation balanced, I know that 4 times 25 is 100. All right, and so now I have plus 25 on this side, which means I am now going to add 100 to this side. All right, and this is all because of that 4, because this right here really is 100, not just 25, all right? So now I'm going to factor out on this side. And I already said that it was going to be minus 5 and minus 5. All right, and so this is what I am left with, okay? So I already said it was going to be x minus 5 because of this minus 10. So this is really just x minus 5 squared times this 4 is equal to this 6, okay? All right, now what I'm going to do is I'm going to divide both sides by 4, okay? All right, and this is what I get. All right, of course, 4 is going to cancel 4 out on this side. All right, and so this is what I get. All right, I'm now going to take the square root of both sides. Okay, this is what you get here. All right, and of course, on the left side, I'm just going to be left with x minus 5. And on the right side, I'm going to be left with plus and minus 6, the square root of 6 over 4. All right, well, when I look at this, I know 6 isn't a perfect square, but 4 is. So I'm going to rewrite it and simplify. Okay, so that's what you get. All right, so our answers are going to be, once I move 5 to the other side, x is equal to 5 plus and minus the square root of 6 divided by 2. All right, here is my next problem. I already written it down for you. All right, so when I look at this, again, I want to move the 12 to the other side because that's just what we're used to doing in math. But we're not going to do that because I don't have any numbers that I can multiply and get a product of 12 and then add and subtract or and get a sum or difference of 2. Okay, so what I'm going to do now is I'm going to complete the square on the left side. Okay. All right, so now I'm thinking about this -2 and this -2. All right, so what's that going to cause me to do is I need two numbers that I can add together and get 2. Well, that's going to be 1. All right, and because these are going to both be negative, that means those ones are going to have to be minus, but multiply a minus times a minus and you get a positive 1. All right, so I get +1 on both sides. Okay. All right, and now what I'm going to do is simplify the right side. And I'll get x squared minus 2x plus 1 equals 11. Oh, I'm sorry, 13. I'm subtracting 13. My apologies. All right, now I want to say that we already discussed that this right here is really just going to be x minus 1 squared, okay? All right, so I get x minus 1 squared is equal to 13. So I'm going to take the square root of both sides. And I get x minus 1 is equal to the square root of 13. I'm going to now add 1 to both sides. All right, so x is equal to 1 plus or minus the square root of 13. All right, here's the next problem. Now, what I want to do with this one is I'm going to multiply everything by 2 because remember, to get rid of a fraction, all you have to do is multiply everything by the denominator. So I'm going to do that. All right, so I am now left with that. And to me, that's going to be a lot easier for me to work with than doing the fraction part, okay? All right, so now what I'm going to do is I'm going to go ahead and complete the square. I am thinking in my mind of two numbers that I can get a sum or difference of 12, and it's going to be 6. So 12 divided by 2 is 6. So I'm going to do r squared minus 12r. Well, 6 times 6 is going to give me a positive 36. Okay. Oh, I'm sorry. It's going to be... No, that's right. 36. All right, and then I'm going to have to add 36 to the other side. So I have r squared minus 12r plus 36 is going to give me 40. All right, and now I'm going to rewrite this part here. It's going to be r minus 6 squared. All right, take the square root of both sides. Okay, and that's what you should have. All right, now I'm going to add 6 to both sides. All right, and I'm going to leave it like that. Now you can simplify this because you can take 4 out of the 40, but I'm going to leave it like that. All right, problem number 3. I got it written down. All right, the first thing I'm going to do is I'm going to take 2 out of this 2p squared and this 8p. So divide both of these by 2. You should be left with all right. Now I am going to go ahead and complete the square. And so I know that 2 plus 2 will give me 4. So plus 4 on this side. All right, now this is where it becomes tricky because 2 times 4 is actually 8. So I have to add 8 to the other side, even though I only added 4 to this side. All right, and 7 plus 8 is 15. All right, so this is what I have so far. I'm going to now rewrite this portion because this is really just going to be p plus 2 squared. All right, that's what you should have. You're now going to divide both sides by 2. Take the square root of both sides. All right, and you should have p plus 2 is equal to plus and minus the square root of 15 over 2. I'm now going to subtract 2 from both sides. All right, and this is what you should have. So p is equal to minus 2 plus and minus the square root of 15 over 2. All right, the last problem. Here we go. All right, so the first thing I'm going to do with this one is I want to move that 5, okay? I'm going to move the 5 to the other side. So I'm going to add 5 to both sides. Okay, so you should get that. All right, now I'm going to divide. I'm going to take 2 out of the 2y squared and the 3y, okay? So here's what I'm going to have. So divide both by 2. All right, this is what you should have. All right, and now I'm going to complete the square. All right, there we go. And what I'm thinking about here is the 2 numbers I'm adding. That's going to give me this 3 over 2y, okay? And then remember, you don't need the full. You only need half of it to go on the other side, okay? All right, and now when I look over here, well, this is really going to be 3 over 4. That's what that is if you take the square root. All right, so for the sake of time, I had to go ahead and get some of the work done. So if you can see up here, once I did this part here, I divided both sides by 2. All right, and this is what I get when I divide both sides by 2. All right, now I'm going to take the square root of both sides. All right, and nice thing for me here is that the square root of 81 and 16, those are perfect squares, so I get 9 and 4. All right, now I'm going to subtract 3/4 from both sides. All right, and so it's going to be y equals plus and minus 9 over 4. Well, I can do the plus part. It's going to be 6 over 4. All right, so 6 over 4 is 1. That's for the addition part. And that can be reduced, of course, to 3 over 2. And then the subtraction portion is going to be 12 over 4, which is going to give me negative 3.